Hello, this is Mr. Stewart bringing you the 7.5 quiz all about scale drawings. Scale drawings are just a continuation of ratios and proportions, which was, chapter 6 and chapter 5. But we're going to continue with this, and it is more geometric in nature, but there's a lot of ratios in geometry. So the first thing you need to understand about this is, well, let me read the question. Question number 1 reads, two triangles are similar shapes. That idea similar is very important here. Use the knowledge to find the unknown side length called x. So if these two triangles are similar, that implies that they are the same triangle. Meaning this is a right triangle, this is a right angle, this angle is the same as this angle is the same as this angle. They are all the same. The only difference, you may say, is its size, right? Because this triangle down here is a different size than this triangle up here. The one up here is bigger, the one down here is smaller. So as you look at this, I want you to think, okay, well, if this was scaled down, okay, but it's the same size, it was just scaled down. Like imagine if you're embedding an image on the computer and you're trying to increase or decrease it, you're going to grab it by the corner and scroll it in or out. But the side lengths decrease or increase proportionally. So if this was 5.5 centimeters, it has now decreased to 2 7/75 centimeters. And then this bottom right here was 9.5 centimeters, and it was scaled down proportionally. So the idea is that like this number has been scaled down, but this number will also be scaled down in the same proportion. So my hint for you would be to set up a proportion, set up a ratio, two proportional ratios. And it may look something like this. Like, I'm going to make up my own example. Let's say I had a triangle that was like this, and then a triangle that was like this. Let's say that they're similar triangles. Pretend they are. If this was 2 and this was 3, but then this was scaled down by 1, and what would this length be? Well, I could set up proportional ratios. I could say 2 is to 1, right? 2 is to 1, as 3 is to x, as 3 is to x. These proportional ratios will help me cross multiply and divide to find out what x is equal to. So, and really, a lot of you might look at this and go, oh, this is decreased by half, so that'll be easy. So that means that x should be equal to 1.5. You could also cross multiply and divide to figure that out as well. 2x is equal to 3 times 1, which is 3. Divide both sides by 2, and you get x is equal to 3 halves, or 1 and 1/2. So that's what x is equal to. Use that to help you figure out the unknown over here. Just a quick note, make sure that you put how many, just the number, and then I've already marked centimeters, and then you don't round or anything, just give me the precise number. Okay. Alright, so this is a trapezoid, and the trapezoids are similar shapes. So the larger one has been increased by a scale factor of 1 to 3, so the ratio 1 to 3, that's important. The question reads, find the missing lengths of all 4 sides. Well, you're given the 4 lengths of the trapezoid underneath. Each one was increased, so by a factor of 1 to 3. And what that means is, if I had a distance of 1 centimeter, let's say that was 1 centimeter, and then I increase this by a factor of 1 to 3, that means it would increase by 3. So its increased would be 3 centimeters now. So each centimeter increases by 3, scale factor of 1 to 3. Use the space provided down here to help you input the correct answers. Okay. I hope this is helpful enough. Okay, the map one. Let me just kind of take a look. So what you have down here at the bottom, column A, there are 4 pairs of cities that have distances, so like Miami to Naples, or Naples, I don't know how you pronounce it, Naples to Orlando, so from here to here, Tampa to Saratoga, so from here to here, and then there's one at the very top, Pensacola to Jacksonville, which is at the very top here. Okay, so that's right, Pensacola to Jacksonville, and the question is simple. Using this map, help or figure out about how many miles away each city is, and that's about, so you have to kind of use things to narrow some answers down. Let's make one up. Let's look at just and the last thing you need to understand is we're using the key down here, that scale right here. So this is showing, if this were an actual printed map, it would show that 1 centimeter is worth 50 miles. So the scale factor is 1 centimeter to 50 miles. So let's look at maybe Fort St. Lucas to Orlando. Okay. Well, if one of these from here to here was 50 miles, then I could kind of estimate it and maybe go, okay, that's 50, maybe that's another 50, that's 50, maybe that's another 50, and then maybe that's just a little bit more, like, I don't know, maybe that's 25. So I would estimate, now it's not exactly, but I would estimate that the distance between these two cities here, these cities, is approximately 125 miles. I'm using this to help me figure that out. You're going to want to do the same thing with all the cities below. Okay, this one I spent a good 20 minutes in class discussing specifically because a lot of students are going to get confused with this. First of all, the area of a rectangle is very elementary. Okay, so if you're not remembering how to find the area of a rectangle, I will just give you a hint. It's base times height. So if we're talking about area, there it is. Now, if you don't remember what area is, stay tuned. We're going to go into that for the next chapter. But this is, I want to say, like 4th or 3rd grade content, finding the area of a two-dimensional shape. If not, then at least it was taught into the 6th grade. It's not even part of our core. It's prerequisite. So you have to know what the area, how to find the area of a rectangle. So you have a diagram or a model of the pool, of a swimming pool here. And the scale factor is 1 millimeter to 4 feet. So for every 1 millimeter, that's actually going to equal 4 feet in the real world. So, I've got 11 millimeters here and 17 millimeters here, and that's going to be helpful to understand. Okay. And the question reads, the area of the actual swimming pool is blank. What is the area of the real swimming pool? And let me just give you like a little example here. Let's say I had a rectangle here, and let me keep it super basic. Let's say this is 2 and 4, and let's say that was the scale model. Okay, so this isn't going to be a very big swimming pool. It's going to be more like a hot tub. But let's say this was, so 2 millimeters and 4 millimeters. Let's just pretend. Okay, that means that its actual size, the actual swimming pool would be 4 times as big this way, and 4 times as big this way. So 2 times 4 is 8, and then 4 times 4 is 16. So the actual swimming pool is going to be some sort of swimming pool that's 8 feet big by 16 feet big. Okay, and so I guess that's a good enough swimming pool to enjoy, just a small one in the backyard, right? So an 8 foot by a 16-foot swimming pool. And here's the error that a lot of students are going to make here. So what students are going to want to do, and this is going to be incorrect. I'm just going to show you this. A student's going to take this and multiply it by this and get 8 and tell me that the area of the model swimming pool is 8 millimeters big. Okay, squared. 8 millimeters squared big, which is true, by the way. That is the area of the model swimming pool. Then they're going to take this idea and scale it up by 4, and they're going to go, aha, okay, so that means that 8 times 4 is going to give me the area of the real swimming pool. 8 times 4 is 32, so the area of the real swimming pool should be 32 feet squared. Now if you thought that, and you're thinking, haha, I got it, and you're wrong. That is an incorrect answer. And I'm going to keep that up there for just a second. And remember, what did I find here? Just barely. What is 8 and 16? If that was my actual swimming pool, what would be the area of an 8 by 16 pool? And as you're doing this, I want you to understand, okay, well, area is just base times height. So take 8 and multiply by 16. What do you get? You actually get, so if you do 8 by 16, you actually get 128 feet squared, which is not, I repeat, not the same as 32 feet squared. So if you just found the area of the model and then scaled it up by 4, then you're not going to get the correct answer. But watch this. Take this number, take this 32 and multiply that by 4. If you take 32 and multiply by 4, you actually get 128 as well. So what's happening here is when you're scaling the area up by 4, the problem is you're only scaling it by a factor of 4, but area is all about the squared amount of space. So really, you're going to have to increase it by a factor of 4 squared when you're working with area. So the distance, here's the best and easiest way to do this. Scale up your side length first. 11, scale it up by 4. 17, scale it up by 4. Find the actual distance of each length and width of the swimming pool, and then just take those two numbers and multiply them together to get the area. That's going to give you the area in feet squared. Once you're done, just put the number here, and don't bother putting the feet squared symbol. I hope this was helpful for you. I'm going to end this now and have a great day.